In this video, I'm going to go over Unit 1, Lesson 3, which is about index laws. And index here is another word that means exponent. So these are rules for simplifying expressions that have exponents in them. Index is another word that means exponent. So this is an image from our textbook, page 17. If you're looking for one place where you can find all of the exponent rules, that's the place to go. And on the remaining slides, we're going to go through each of these rules and practice them with examples. So this first rule is about when you are multiplying two powers together. So product is a word that means multiplication. A product of powers means when you're taking one power and multiplying it by another power. And a power, remember, is a base and an exponent together. So if you've got a base exponent and you're multiplying it by another base exponent, what it says that you're supposed to do is add the two exponents together. And notice that the bases have to be the same, right? They're both a base of a if you're going to be combining them. So in the first example, we have to look for two bases that are the same. And I have this x squared that has the same base as this x to the fourth. And it is a product because when you've got the two parentheses touching like this, it means multiplication. So we're going to take x squared, multiply it by x to the fourth, and we're going to end up with x to the sixth power. Because if we're following this rule, it says to add the exponents together. The reason why that is, if you want to see it out one time, is that x squared actually means x times x, and x to the fourth means x times x times x times x. And if you look at how many x's are being multiplied together, the total of them is 6. So you're doing x to the sixth power, and that's why the simplified version of this is x to the sixth. Follow the same pattern for the y's, and you end up with y to the eighth power. Can't combine the x's and the y's, so we're going to leave them right next to each other like this, showing that they are multiplied, but I can't combine them. In this next example, we have a couple of added tricks to it, which is that we have this 3 coefficient and this 4 coefficient that are being multiplied, and those are not powers. They're just the number 3 and the number 4. The other problem is that I see y's in here and this x in the second parentheses that don't have an exponent on them. That's because there's just one y, or there's just one x. So you can think about it as having an exponent of 1 if that helps you visualize how to do this rule. So now to simplify, I'm going to take the number 3, I'm going to multiply it by the number 4, and give my coefficient of 12 in the answer. I'm going to look at the x's and see that I've got x squared in the first parentheses, x to the first power in the second parentheses, and know that that means I'm multiplying 3 x's altogether, so x to the third. And then I have y to the first and another y to the first being multiplied, and that gives me y squared. And that's the simplified version of this product. Okay, the next rule is about raising a power to another exponent, so the power of a power. So inside these parentheses, I have a to the m exponent, and then on the outside, I am also raising it to the nth power. And it tells you what to do here is multiply the powers together, leaving the a as a, right? Leaving the base as the base. So in this first example, I have y to the third power, and then outside of those parentheses, I have the third power. So we think about what do we know about exponents, that the thing in the parentheses here is the base, and that base is supposed to get multiplied by itself the number of times that you see on the outside exponent. So I'm supposed to take y to the third and multiply by itself 3 times. And so if I was to actually write all this out, you'd see I have y times y times y, another y times y times y, and another y times y times y. And altogether that is 9 y's being multiplied together. Therefore the answer is y to the 9th power, which is what the rule said we should do. It said we should take the two powers, m and n, and multiply them together to get this answer. And 3 times 3 is indeed 9. It's a little trickier in the second example, where the thing inside the parentheses is more complicated. I'm going to take each of the exponents inside of the parentheses and multiply it by the exponent outside of the parentheses. Remember, that's what this rule says to do. It says to multiply the exponents and leave the base alone. So in this problem, example 2, I'm going to leave the bases alone. I have a 4, I have an x, I have a y. I'm going to take the exponent that was there and multiply it by the exponent that is outside of the parentheses. And so this is going to end up being 4 to the third power, because 1 times 3 is 3. This is going to be x to the third power, and this is going to be y to the 9th power. There is one more step I can go here to simplify because I don't like seeing my answer with 4 to the 3rd power, since that's an operation that I know I can do. It means 4 times 4 times 4. So I can at least simplify that part of this expression and make it a 64. But then I'm going to leave x to the 3rd and y to the 9th in my final simplified answer. The next rule is about negative exponents. And this is kind of a tricky one. What you see in the rule is that if you have a negative exponent, like in this example, what you're supposed to do is write your answer as a fraction with 1 over the same expression but with a positive exponent. Kind of interesting. And then the reverse of that would be if you see a negative exponent and it's already in a fraction, you undo the fraction or you bring it up to the top and you change the power to positive. So this is a really confusing rule. I want to show you where it comes from so that you can maybe understand why we do this. So I'm using the example of the number 5 as a base in this number line here to show you where this rule comes from. If we evaluate from left to right, we're going to do the positive side of this number line so that you can see the pattern. 5 to the 3rd power, we'll do a dot, dot, dot to show this pattern would go on forever, but we're going to pick it up with 5 to the 3rd power. 5 to the 3rd power is 125. Then you've got 5 to the 2nd power, which is 25. And then you've got 5 to the 1st power, which is just the number 5. And if you notice what's been happening so far, as you go from number to number down this number line, as the exponents decrease by 1, you can actually think about it as division by 5, right? If I go this way to get to the next number, I have divided by 5. And again, if I go this way to get to the next number, I have divided by 5. If we continue this pattern, as the exponents continue to decrease, the next thing that we should do is divide by 5. And 5 divided by 5 is the number 1, which might surprise you, because if you're mapping this onto the list, we see that 5 to the 3rd power is 125, 5 to the 2nd power is 25, 5 to the 1st power is 5, and it turns out that 5 to the 0th power is 1. And it turns out that anything to the 0th power is 1. So it's a note that you should write for yourself. Anything with exponent 0 is 1. That's because it is the base divided by itself. No matter what we put on this list, if we tracked it all the way down from an exponent of 3 to 2 to 1 to 0, when you get to any number to the 0th power, it's going to be that number divided by itself, and that gives us a 1. If I then continue the pattern, we get into negative exponent territory, and as I divide by 5, the result on my list is 1 divided by 5, and that's where the fraction appears. So the fraction that's in this rule is once you're into negative exponent territory, our answers have fractions in them. There are no negatives anywhere. They're just fraction versions of the positive side of this number line. Because what I'm doing each time is dividing by another 5, dividing by another 5. Notice there are no negatives in the blue, right? There's no negatives on the number line. Only the exponent is a negative to show you that we're now in fraction territory. And that's why the rule has fractions. Now, you don't actually need to know all of that about this whole chain of 5s and fractions and all that. You just need to be able to follow the rule, but I wanted you to see where it comes from. So if we're going to follow the rule for this example over here, I see negative exponents in a couple of places in this problem. The first thing I want to do is deal with this outside negative exponent, because it's a pretty easy fix to say, I know the rule says I'm supposed to write my answer as a fraction. So if I look up at the top, it says when you have a negative exponent, you should write your answer as a fraction. In fact, let me just try to drag this down so I have a little bit more space. Okay. So I'm going to try to write my answer as a fraction with 1 on top, the whole power written on the bottom. Up in our example at the top, it was a to the m. So you just wrote it on the bottom as a to the m. Here it's a bit more complicated than a to the m. It's this entire thing. This entire thing is the base with a 4th power. So the first thing I did was just to rewrite this thing as a fraction, changing the -4 to a +4. That's following the rule on this slide. The next thing I need to do is follow the rule from the previous slide where we talked about power to a power and deal with this 4 that's outside of the parentheses. So what we learned in the previous slide was we're going to fill in the exponents on the inside of the parentheses and multiply the 4 times all of them. So I'm going to go on to a new line, continue to simplify this thing. It is still 1 over, and then on the inside it's going to end up being 3 to the 4th, x to the negative 8th, and y to the 12th. And I'll deal with that negative 8th power last. Okay, I'm going to keep going with this. Just like on the previous slide, I have a number that I can just simplify. I don't even need these parentheses anymore, by the way, because I've dealt with the exponent. There's nothing else outside of these parentheses, so I'm just going to drop them at this step. And I have 3 to the 4th power, which means 3 times 3 times 3 times 3, which is 81. And then I've got this x to the negative 8th and y to the 12th. Now this would be a great answer, except there's a rule in the simplifying of algebra that we can't leave negative exponents in our answer. And this is when we get to use the second rule that's at the top of this page. Scrolling back up so you can see it again, the second box. If you already have a fraction with a negative exponent on the bottom, then you're meant to whip it up to the top and make that exponent positive. So bringing that bottom negative power up to the top and making it a positive power is the way to eliminate this x to the negative 8th. So in the end, the x to the 8th is going to come to the top of this thing and join the number 1 that was there. So now I don't need to show the 1 anymore, because 1 multiplied by x to the 8th is just x to the 8th. And then I'm going to keep the 81 on the bottom where it belongs, and the y to the 12th on the bottom where it belongs. And this is the simplified final answer. I know that these rules are going to take a lot of practice to get right, especially with negative exponents, so we will get that practice. This one's a little bit easier. This is to say power of a product. So if you've got a bunch, and we've actually been practicing this one, that's why it's easier. If you've got a bunch of things inside the parentheses being multiplied together, you actually take the exponent in, multiply it by each power, and that's how you end up with this a to the m and b to the m. So we've been doing that. This just gives us another chance to practice it. So anytime we have parentheses with a power on the outside, like this one and this one, we know now we're supposed to fill in all the powers inside and then distribute through. So we're going to take that power and multiply it by the powers inside. This is going to become 2 to the 3rd, this is going to become x to the 3rd, and this will become y to the 6th. Keeping the parentheses because there's a whole separate set of parentheses here that I'm still dealing with. This is going to become 3 to the negative 2nd, x to the positive 8th, and y to the positive 10th. Now I've dealt with the power of product, and it's just a matter of simplifying using all the other rules I've learned. So first I'm going to go about simplifying these numbers. 2 to the 3rd power is 2 times 2 times 2, which is 8, leaving those powers alone for now. Then I'm going to deal with this 3 to the negative 2nd power. I know that 3 to the negative 2nd power means 1 over 3 to the 2nd. We learned that on the previous slide, where if you have a negative power, you're supposed to drop it to the bottom of a fraction, make it a positive power. And I know that 3 to the 2nd power is 9. So at this same step, I'm going to go ahead and make this 1 over 9. And then I still have this x to the 8th and y to the 10th, which are not part of the fraction, they're separate. Now I'm going to simplify. I know I've got a multiplication problem. This is the first rule we learned. So the numbers, the 8 and the 1/9, are just going to get multiplied together, giving us 8/9. Then I've got x's. I've got x to the 3rd power, and I've got this x to the 8th power. And I know that that means I'm multiplying 3 x's and then 8 more x's for a grand total of 11 x's. This is the add the powers rule. Then I've got y to the 6th multiplied by y to the 10th. Again, that means I'm multiplying all together 6 y's, 10 more y's, giving us y to the 16th power. It's the add the powers rule. And that's the simplified version. So once we get into these examples that combine all the rules, you may have to go many, many steps down this thing to keep getting it simpler until you're at the most simplified version of the answer. 0 exponents, we wrote this down on a previous slide, so now we're just having another chance to practice it. Anything to the 0th power is 1. This first example is therefore super easy. The base is this, power is a 0, therefore the answer is 1. It doesn't even matter what the base is, because the 0th power means base divided by itself, and that's always 1, no matter what the base is. So this next one, it has a trick to it, which is just the order of operations. So you remember you're supposed to do exponents before you multiply. And so in this case, I'm actually supposed to do x to the 0th power first, then multiply it by the number 2. And so in this case, it's actually 2 times 1, and the answer is 2. So just be on the lookout. Just because you see a 0 power doesn't mean you always just get to write 1 as the answer, because there might be other things you're supposed to do to the 1, as in this example. What about when we've got division? So if you've got a power divided by a power, the rule says you take the top power and you subtract the bottom power, as long as the base is the same. And so in this first example, I'm supposed to take the top power and minus the bottom one, which is actually just x to the first power, or just plain x. The reason why, again, I like you to see the reason, even if you go on and forget that. The numerator here is x to the third, the denominator is x to the second, and if you go ahead and cancel these, you'll see that what you're left with is a single x, and that's how our answer ends up being just plain x. But if we just practice the rule, that's fine too. So in this one, I'm going to go ahead and do top exponent minus bottom. Same for the y's. Simplify that. It gives us x to the negative second and y to the negative fourth, which would be great, except for that I can't leave my answers with negative exponents. So I have to remember, oh, I meant to do this as a flip and this one as a flip. Remembering that negative exponents actually just mean fractions. And then I just don't want to leave my answer as two separate fractions because I can multiply 1 times 1. And I can multiply x squared times y to the fourth just by writing them together. And that's the final answer there. This one gives us a chance to practice all the rules together, because this is the one that says, just like when we had a parentheses with an exponent before, and we bring it in, and we bring it in, we can still do that same thing when there's a fraction. You bring in the outside power to every power that exists inside of the parentheses. So make sure everything has a power on it, including the 2 and the 8, all right? Any just plain number has a power of a 1 on it. And we're going to bring in that outside power and distribute it to every exponent that lives inside of this parentheses. That's a lot of distributing, and I'm going to have to erase this because it just got super messy. But we're going to bring in that outside power, multiply it by the powers inside. So I end up with 2 to the negative second, x to the positive sixth, y to the positive eighth. I like that we made those positive. But on the bottom, 8 to the negative second, x to the 0th, because 0 times negative 2 is still 0, and y to the 14th. When I go about simplifying these, I have positive exponents on everything except for the 2 and the 8. Now to make them positive exponents, though, remember, you can just switch where they are on the fraction. If you move it to the bottom, you get to make it positive. If you bring the bottom one up to the top, you get to make it positive. If I switch them, I get to make them both positive. Everything else already was positive. We're still in good shape with the x's and y's. And now I'm going to simplify the numbers. So 8 to the second is 64. I'm going to keep my x's and y's alone for a minute, leave them alone. 2 to the second is 4. Got lots more simplifying to do. This is the mega example. 64 divided by 4 is just 16. Now I'm supposed to do top minus bottom. So 6 minus 0 for the x's, 8 minus 14 for the y's, which gives me x to the 6th and y to the negative 6th. And then the very last thing I need to do is deal with this negative power because I know I'm not allowed to have it in my final answer. So it's 16 x to the 6th. This I flip, and then we're not interested in leaving our answer as a separate fraction. But luckily I can do 1 times this on the numerator. And the denominator is just y to the 6th. It's like there's an over 1 here. So when you multiply by 1, the 1s don't matter. And this is the simplified final answer with no negative exponents left. And that is all.